Okay, here we are in our second section, and let's go ahead and take a look at some examples, and we're going to kind of break down why, when, and where are we going to use these functions, and how does that relate to classifying functions. So, in our very first example, I want you to evaluate the function f of x equals 3x minus 4 when x equals 7. Now, before we tackle this, I want to ask you, thinking back to our last video, is this an even or an odd function? Remember, we look right here at this exponent of x, and you'll notice since there's not one there, it's assumed to be a 1, and because it's a 1, we know that this is in fact an odd function. Okay, now what are we really saying here? We're saying x equals 7. You go into this function and you find everywhere where you see the letter x, and we're going to replace that with a 7. Now what I would always encourage you to do is to write the function, and where you see x's, first write them as parentheses, taking the x out. So you'll notice I have a blank spot here, I have a blank spot here. And we're going to go into that blank spot and we're going to fill in what x actually is. So here I'll plug in 7, I'll plug in 7, and now we can start to solve this down. We can say f of 7 is equal to, remember when two things are side by side they're being multiplied, excellent, and 3 times 7 will of course give us 21. I drop down that minus 4 and we have 21 minus 4, which will in fact give us 17. Now, what's important here, f of 7 equals 17, is how this relates to a graph. Let's say I know that this is a linear function, and I know that this is our only straight line function, and it's going to look something like this. What does f of 7 equals 17 really mean? Well, it means that on our x-axis, if we were to go all the way over here to 7, let me just scribble that out, 7, and we were to go up to right here, well, we would know that it's going to be at a height of 17. So this is allowing us to evaluate a specific point on the function. I would pause this, finish taking your notes, and let's move on to our second example. Okay, here we are in example 2. Now what if I gave you the function, and instead of using f of x, I give you h of x, which really doesn't change anything. It's just saying, hey, we have a different function, and I give you 3x squared minus 5x plus 2, and we're going to evaluate this where x is equal to 4. Well, once again, how would I encourage you to start this problem? I would have you write it where you leave out everything except for the x. So 3, and instead of x squared, we'll write parentheses squared minus 5 parentheses plus 2. Now once again, shifting colors, because I think this really helps. We know x equals 4, and so in place of x, we are going to put a 4 everywhere where x used to be. Now this allows us to begin working this down, and we're going to have to follow our order of operations. In fact, I'm going to write this over here, PEMDAS, and when we're simplifying, we're actually doing PEMDAS in its normal order. So we have nothing going on inside the parentheses, so we're going to take care of this exponent first. And what does 4 squared really mean? Well, 4 squared means that this 4 is actually there twice. We're saying 4 times 4. And so we can say 3 times, well, 4 squared, 4 times 4 would be 16. Now here, because this is its own separate group, we can go on to the multiplication. And what is negative 5 times 4? Well, of course, that'll be negative 20 plus 2. And we'll just keep that the same. Moving on down. Now we have h of 4 is equal to 3 times 16. We're still in our multiplication phase for this one. I would encourage you to use a calculator. I'll have one linked in the practice for you. And of course that would be 48. Now here we have a negative 20 plus 2, and we can go ahead and tackle our addition. And what is negative 20 plus 2? Well, remember, positives and negatives take away from each other, so negative 20 plus 2 would actually wind up being negative 18. Now moving on to our very last step, we have h of 4 is equal to 48 minus 18, and of course that will give us 30. Now the thing I didn't ask you at the beginning of this problem was, is this an even or odd function? And when you look at that 2, that largest exponent, you should know it is in fact an even function. And what are we saying here? H of 4 equals 30. We're saying that if we went over to 4 on the x-axis and we went up and we hit this graph, it would be hitting at a height of 30. And that's how we can evaluate this broad function at a specific point. Go ahead, pause this, and let's move on to our next example. Okay, here we have example 3, and let's do something that looks a little bit trickier. Let's say g of x is equal to 4x cubed minus 7, where x is equal to 2. Now I want you to notice something. Here we have a 3 in the exponent. How would you describe that? Is this an even or an odd function? Yeah, and of course, because it's a 3, it's going to be an odd function. Now over here, we have x is equal to 2, and we only see x's right here and here, so once I replace those with parentheses, we can fill in that 2 from what x equals. So we have g of 2 is equal to, and remember, according to PEMDAS, we have to take care of that exponent first. Now really hear me out. What does 2 to the third power actually mean? It means that we have 2 times 2 times 2. We see that 2 is there a total of 3 times. And of course 2 times 2 is 4, and 4 times 2 will give us 8. And so we see that 2 cubed is actually 8. Following on down our order of operations, we do our multiplication. Use a calculator if you have to. 4 times 8 will of course give us 32 minus 7. And lastly, we know that g of 2 will be equal to 32 minus 7, which is 25. Okay. Now once again, as always, I want you to understand what is going on with our graph. Well, we have an odd function, so it looks like this. And we're saying when x equals 2, so like let's say that's 2, if we go up to this graph right here, well, what height is it at? It's at a height of 25. Okay. Well, we've got one final example. Let's go on to that. You know what? In fact, yeah, let's go on to that. Pause it. Let's move on. Okay, last one. Example 4. And look, I think most of you get it, so I'm going to make this very, very quick. What if I gave you two functions? What if I said, hey, here's f of x, and we'll say f of x equals 2x plus 1, and I said, hey, here's g of x, and g of x is equal to negative 4x minus 8. And what if I said this? I want you to find which one of these functions has y equals 7 when x equals 3. When x equals 3. Which one of these functions has y equals 7 when x equals 3? And remember, y is just another way of saying f of x or g of x or h of x or w of x or any letter of x. It's another way of saying y. Well, all you would have to do is literally plug in x equals 3 into both of these and evaluate them. So for example, we know that our f of x would equal 2 parentheses plus 1, and our g of x would be g of parentheses equals negative 4 parentheses minus 8. And in both of these cases, we are simply going to plug in a 3. And we want to figure out which one of these will give us an output of 7. Okay, so let's go through. So we have f of 3 is equal to 2 times 3. We know that that is 6. We drop the plus 1. And of course, what is 6 plus 1? Well, that is 7. So it looks like right now our answer is going to be f of x. However, let's just go ahead and evaluate g of 3. So let's say g of 3 is equal to negative 4 times 3, I should have written that in, which would be negative 12 minus 8. And of course, negative 12 minus 8 will be negative 20. So, did g of x give us 7? Well, the answer is, of course, no. Alright, I hope this helps you out with this section. Good luck, and I'll see you in our next section.